Then I'll give you some of the details on the acoustic imaging, how sound waves travel, things that one of my counterparts in Tennessee introduces by saying, these are things you don't really need to know to use an ii900. And then we'll talk about, well, determining the cost of, in our case, I've highlighted here LeakQ, determining the cost of an air leak. You may or may not know, in fact, you may want to get off after I tell you this, but these things are $20,000. And so obviously to spend that much money on an instrument like this, you have to be confident that there's a return on that investment. So we have some tools to help you calculate that. And I'll just show you some of that as we go along. But first, if you look at the PowerPoint here, it says what is acoustic imaging? What is a sound map? Maybe another way to put it. I'm going to read this kind of slowly. It's a technique for creating a visual image based on sounds. Then step 2 here, the sounds are measured within the field of view of a video camera. And then the sound image or the sound map, it's just overlaid on top of the video image. So what you see here on the right is a leak in a compressed air line. So the color coding here, that's the sound map. Everything else is just standard video camera. If you look at the instrument, you see the video screen here on the left, the detector, the sensors in this thing. There's a visible light camera right in the center. And that's surrounded, if you can see the little holes, there's 64 microphones surrounding the camera. Then it says we use triangulation to build a sound map. We overlay the sound map on the visual image. If you think about it a minute, without going into a lot of detail about how sound works, if there's a noise over here on the right side of my head, the sound wave travels, hits this ear first, and then it hits this ear, okay? My brain can detect the difference. You know, the sound wave hit here, then it hit there, plus it's louder on this side. So my brain will figure out, oh, it's over there. Well, with an array of microphones on the detector, you can tell where in space the noise is coming from. And I'll keep talking about leaks, but we're really just talking about sound. This thing can be fooled. Not everything making noise is actually an air leak, but you kind of get a feel for how it works. An array of microphones, we figure out where in space the noise is coming from, and then we just light it up on the video screen. Now this, just to note, this is new for Fluke. The technology is not really new. It's probably the first time you've seen it. It's been around a while. We're the first ones, though, really to package it in an industrial camera that you can take out and, you know, use in a plant looking for air leaks. And we kind of highlight air leaks here. If you look at the first picture below, there's an air leak, but also gas leaks. I like this picture where you can see the guy's hand. You see it looks like he's holding the little red spot. That's the leak. That's an argon gas leak. And the man whose hand is in the picture looked at me and he said, "This is gold dripping on the floor." These folks did a lot of welding. The argon gas is used for welding. If you notice, there's nothing hooked up. Somebody just failed to tightly close that valve. It's amazing how many times you see just carelessness closing off a compressed air valve or a gas valve like that. Then the next image over here is a vacuum leak. And then the last one on the right is a steam leak. The vacuum and steam are a little harder to find because typically they're lower pressure. Vacuum, I believe it's true to say the vacuum, rather than project the sound, it actually comes inward. That kind of sounds good to me. I haven't found anything to really back that up. But you see the lady blowing dollar bills. This is my favorite picture here because that's really kind of what the ii900 is all about. Is yeah, it's an expensive instrument, but my customers are telling me that I'll hear comments like, the most expensive thing we make in this plant is compressed air. Now, I had no idea, but let me just quit talking a minute and show you a little video on somebody using this thing, so you'll see what the sound map, what we're talking about here.
We count on air for a lot of important things. Compressed air is everywhere. We don't always think of the pain leaks cause. Leaks can stop us in our tracks. What could you repair if you had an easy way to pinpoint a leak, even from a distance, and save money? If you rely on compressed air, you can now forget about the old messy way of finding leaks. The new Fluke Sonic Industrial Imager uses patented sound sight technology, enhanced scans to clearly see leaks you can't even hear. The Fluke ii900 Sonic Industrial Imager works in noisy places without having to shut down the line. Scan large areas quickly so you can find leaks much faster and improve your bottom line.
Two things we'll come back to here. One is this, up to 30% of compressor output is lost. And the other, remember the comment about works in noisy environments. Those both are pretty important when you're trying to get a handle on just what an ii900 is. But the comment about 30% losses, if you look at the circle here, this comes off a DOE website, and there's reference to the DOE website down here. So they estimate, typical plant and typical of my customers that I've shown this to concur that 10 to 30% losses from your compressor is not unusual. I told you that a lot of folks had told me the most expensive thing we make here is compressed air. If you look in the upper right-hand side, it says 7 and 8 horsepower. That doesn't sound right, does it? Well, to get 1 horsepower's work, 1 horsepower of compressed air, you have to put 7 to 8 horsepower into that thing. So I think it would be fair to say to get $1 worth of energy in pneumatics, you've got to put $7 to $8 worth of electricity into these things. And I just had no idea how expensive it was. I'm old. I'm basically a voltmeter salesman for a long time. When I walk around an industrial site, I don't really notice all the tubing and the pneumatics. I'm more attuned to the electrical stuff. But now, since this thing came out, I've changed my tune quite a bit. What you generally see, and there may be someone on the line who's done this, but conventional tools for finding leaks. Note it says conventional. Here's a keyword: ultrasonic tools. Okay. The ii900 is an ultrasonic tool in a sense also. But you're walking around a plant, there are literally miles of pipe and tubing that potentially could leak. And one way to find leaks in a plant is to wait until the plant's not running, leave your compressors on, you just walk around and listen for leaks. You can hear them with your ears. But remember the video, it says that the ii900 works in a noisy environment. Okay. If you look at my picture of conventional tools here on the bottom, here's a couple of different, I think these are probably different manufacturers, but these are ultrasonic listening devices. Okay? And there's 2 parts to this. You see the headset or the earmuffs, this is important because you're walking around a plant that's running. And all the noise in the plant is pounding your ears. And if you didn't have these mufflers on, you'd have to have earplugs, now as a safety feature to walk around most plants. And then if you looked at the little wand in the picture, you see the guys holding the wand, they got the headset on. The wand is the ultrasonic listening device. So it's a microphone, just like the ii900 has microphones. It's a microphone, though, that you can tune to the ultrasonic frequency band, which is a higher frequency range than we hear with our ears. So with the little wand, we're listening in the ultrasonic frequency band. but the sound that the wand picks up gets translated then into the headset the guy's wearing. So the headset both blocks out the sound of the plant and lets them listen for leaks. Okay? So the ii900 is similar, except rather than let you hear the noise, we're going to show it to you on what we call the sound map. Now I'm going to run through a couple of slides quickly, kind of the basics of, well, these are the things that my counterpart in Tennessee says you don't really need to know to use an ii900. But this is kind of cool. If you look at the slide, it says sound is produced when something vibrates. You know, I mean, sound is mechanical. If you've ever watched a speaker, like the big, what do you call the bass, the woofer or something, you know, on the speaker, you can actually see the thing moving back and forth. It's literally pushing the air. And it is, what's the term? Well, it's back and forth, right? Not cyclical. But a couple of things you can measure. You can literally hook a scope, and I've got, if you could see my basement office here, you'd be amazed at the equipment. But you can hook an oscilloscope up to a microphone or to a speaker and look at sound waves. You've got basically two important things here. One is amplitude, which if you're looking at the waveform on a scope, if it's soft, the amplitude, it's short. If it's loud, it's tall. But if you look over on the right of my screen, you're probably not going to look at waveforms. You're going to look at a reading in decibels, or dB, right? And this little scale shows different decibel levels, everything from leaves blowing down the sidewalk to race cars, blenders to jet airplanes, right? Somewhere around 100 dB, you're probably going to lose some hearing. Where is this? There's a rock concert, say 120 dB. A lot of us with kids are worried about our kids. And actually, when I was younger, I think my parents were probably worried about me too. So I've got amplitude, how tall is the waveform or how loud is it? And then I've got frequency. Now, I'm not musical enough to make different sounds, you know, but a low frequency here on the left is and a high frequency would be ee, you know. If you look at the, so here's high frequency waveforms. If you look at the scale in the middle, and I got this off the internet, so I'm sure it's true. Everything on the internet, right, we can believe. Our ears for humans, audible frequencies, we'll call it, operate from about 20 kilohertz, or excuse me, 20 hertz up to about 20 kilohertz. And on the ii900, we'll talk about what is the audible frequency band is anything below 20 kilohertz. Now, I know I can't hear 20 kilohertz, right? I'm lucky to hear 10 kilohertz. But anything above 20 kilohertz is by definition ultrasonic, okay? Things that we don't hear with our ears, right? Now, you see the little pictures, I'm told, because it's on the internet, that elephants can hear really low frequencies that we don't hear. And bats, and I guess I've lost the picture for dolphins, but bats, dolphins, and you know, your dog can hear higher frequencies than our ears can pick up. But in reality, the sound waves aren't quite as clean as the sine waves that we're showing here. It's all kind of jumbled together. So there's all different frequencies, all different, you know, amplitudes in there. And that's true of leaks too. Now, generally a leak will make noise in the audible range. You can hear them, but also they'll make noise up in that ultrasonic band where our ears don't work. And that's what lets us hear leaks in a noisy environment of an industrial plant. We're going to tune to that ultrasonic band and get the high frequency stuff. Now, a few little things that you need to know if you're using an ii900 or kind of understand. You see the man walking down the hallway here around the cubicle, and here's a printer, I guess that is, or a copy or something that's going. He'll hear this thing before he can see it. So you can hear things that you don't see. And if you look over on the right of this screen, you'll see the sound source. There's the person. So the sound waves are projected out. You know, as I'm speaking, sound waves are going everywhere. If I turn my back, you're still going to pick it up in the microphone over here, right? So you'll see the sound waves, they don't really wrap around the corner, but it kind of looks that way from the perspective of the person. So sound waves travel, they can go around things. You don't necessarily have to, or you don't at all have to be line of sight to hear something. The other thing you have to remember if you're using an ii900 about sound waves is that they do travel from point to point. So there's the source in a straight line to my ear, but also you get reflections because the sound is going in all directions from the source, right? And it'll bounce off the walls. Again, that's me turning my head. I talk, you still hear me. You're getting reflections, or you might call these echoes. We'll come back to that when we look at just using the ii900, but I'll show you a couple of what we call practical considerations. Probably the most important thing to know when you use this is how to deal with reflections. If you just look at the pictures here, I'm not going to dwell on this, but there's a leak in the lower right-hand corner. You can see the tubing here. There's a leak in that fitting, but they first saw it. If you look in the upper right-hand corner, they saw it on the floor. Now, you know, in this case, there's probably not going to be a leak in the concrete floor, right? What's happening is the sound is being reflected off the floor back into the camera. Now, it's likely, and I don't see a list of who's on the screen, but they're likely, there's some folks here with thermal imaging experience. I know you guys at Statesville Process Instruments have been involved with thermal imagers. And, you know, if you look at an electrical panel with a thermal imager and you see maybe three-phase connection and one of them looks hot, you see a red spot on it, but you move a little bit and that red spot moves over to the next phase or someplace else in the camera. What you're really seeing is your body temperature being reflected back off the shiny surfaces in that electrical camera or that electrical panel. With the thermal imager, they teach you to move with the imager to look for reflections. That's exactly what happens here with the ii900. It's important to move. So I'm going to run another video for you to illustrate that. Now, right now, they're walking around, the camera's not turned on, but there's a leak right there. Now the camera's turned on. They're not line of sight with the leak, so we see the sound waves are coming around the equipment. I know something's happening there. There's a quick glance at the leak. When we're line of sight with the leak, you get a steady red spot. That is, it's not moving. So I know that that is the real deal. So there it is. Here's echoes, reflections. I'm not line of sight with the leak. When I get line of sight with it, if you'll notice, there's spots on the ceiling. So I keep moving and there we go. I've honed in on the leak. Now what I want to do as an ii900 user is take a picture, put that thing in a work order so someone can go repair it.
Continue.
Okay. So using an ii900, it's important to understand reflections, to keep moving a steady red spot, or you don't necessarily have to be using red in your color palette. If it's steady, when you move, you're looking at the source of the sound. Now, if you look at this picture, this wasn't shown in the videos. On the ii900, you can turn a dB, remember that's loudness, of the center point on the screen. That's a measurement you can turn on and off, but always there's going to be the color palette here. Now this kind of gives you the idea that, well, we're looking at a thermal imager, but there's nothing thermal about it. Remember, it's a listing device only. If you look at the scale here on the color palette, this is decibels. So in this color scheme, the brighter colors, the white, the yellow, are louder as you come down, and the reds and the purples, so it's not quite as loud. So I've got my loudness or intensity, and if you look on the far right-hand side, you see the scale that's always on the screen. This is the frequency band, and the frequency band, oh boy, supposed to, let me do it that way. If my wife were here, she'd slap me for not coughing in my elbow. But if you look at the frequency band here, An ii900 can hear noise from about 2 kilohertz up to, I think it's 52 kilohertz. I don't remember the spec. And if you look at this picture, you can see there's a bar graph that's always active to show you the intensity of the sound at different frequencies. Okay. But then you see the little box here. Now remember, anything above 20 kilohertz is considered ultrasonic, or what you can't hear. Below 20 kilohertz is audible. So the little box, and this can be adjusted by the user, the little box tells me the frequency band that our sound map is being created in. Okay. So what you see here, the little leak coming out of the bottom of the balloon, is what we're picking up in this frequency band from about 17 to 24 kilohertz. All the noise down here on the bottom, I think, is the person that took this video. I think it's them talking. Now this is actual video off of an ii900. So you've seen a lot of images from an ii900. The ii900 will also record a video, but let me run this little video for you here. And you'll see toward the end of it, they'll start playing with the frequency band. You see the reflections? Now he's playing with the frequency band on the right. I believe the guy who recorded the video is talking too, so you can see down in the audible range his voice changing. So probably the only control a user needs to think about is this frequency band. And generally, if you're looking at compressed air leaks in a plant, you're going to be 30 to 40 kilohertz up here, somewhere above probably 20. And this is done with your finger. It has a touch screen on it, right? So just last slide on practical considerations. This is sort of common sense. Green is easy to detect, red is hard to detect. So the closer you are to the leak, the more likely you are to find the thing. I'm asked a lot, well, what is the distance? I've got a spec toward the end that's related to like 100 feet. You know, I've seen things that I know are 40, 50, 60 feet away, but often in a plant, it's hard to get that far away because there's too many obstructions. But distance affects your ability to find the leak. The pressure, you know, if you're talking about compressed air, it's typically, 90 to 110 PSI. Now, instrument air, you process instrument folks, is generally not that high, but it's pretty easy too, really, to find a 15 PSI air leak on a piece of tubing that's, say, connected to a control valve or something. And then the flow rate, that is, CFM, how fast is it escaping? Something that is a little, let me say, counterintuitive, I guess. If you look at, imagine a big fan, or a lot of times you go to an industrial site, there'll be a gigantic fan in the ceiling, okay? Flow rate's high. Those things are moving a lot of air, but they're not making any noise in the ultrasonic frequency band where we're going to be listening. I probably need a slide for this, but what happens is and we'll talk air or gas, escapes the leak, the orifice that is the leak. If those escaping particles create turbulent flow, that's what generates the sound in the ultrasonic frequency band that we're listening for with the ii900 or any ultrasonic device. But really, it's real hard to put real numbers, the shape of the orifice, the tubing, is it turbulent flow or not? A lot of things affect your ability to actually find the leak. So I've got a unit here behind me. Let me turn the camera around. Okay, see my little demo set up there. Here's, I've got the ii900 and I have a compressed air tank. So I'm going to show you in a minute the screen off the ii900. You won't be able to read these letters very well on the screen, but I can control this. I won't bother anything else. That's really about all you need to do. It is a touch screen, so if I reach out and touch the screen, the little menu will pop up here on the left. You'll see date and time, battery life, etc. displayed here. So let me blow this up. And what you see here, this red tank, that's my air compressor, sort of. Got the gauge here. I've got a valve. I can turn it on and off. So, and a roll of tubing, so probably you can hear air coming out, right? I have another camera on the ii900 display. So this is you can't read this too well, but you see the frequency band there. And as I speak, you see the, clap my hands. So the unit is measuring in the frequency band from 2 kilohertz to 52 kilohertz. But we're only creating the sound map. I've got it set now, it looks like 30 kilohertz to 40. If I slide this down, now when I make noise, you'll see it light up on the screen, right? Let me squeeze that down again, kind of raise it up. And I'm going to turn the air leak back on. So hopefully, my guess is you can still hear it. I can hear it. I don't know if you can hear it on the screen, but you see the little red dot here. And now you see it's making a racket way up into the ultrasonic frequency band. If I slide down here in the same frequency band that my ears can hear it, you see actually the dB level gets a little redder. Red is loud. Usually, if you're going to save an image for someone, though, you want it to be as concise as you can to get better resolution on where the leak is actually. You see this button on the right. If I want to save this image, I push that button, and it just saved the image.
Hey, Rick, adjust your camera a little bit. We can't see the button on the right.
Ah. How about there?
Got it.
Okay, so there's the button. Push the button, touch the screen, and push memory, and you can see images saved. There's the image that I just saved. If I want to just describe the image, I know you can't read this, but it says notes. So I can type in some notes, maybe where it is or how loud it is or whatever. Kind of classic way to identify leaks is to put a little tag on them. The guy with the headset on, since he can't show a picture, what he'll do is write out on a tag some information about the leak, and then he'll just fasten the tag right to the tubing or right where the source of the leak is. So if I had a tag, I'd come put the tag right out here, right, on my leak. Let me stop that leak. So that's really all there is to it. I'm going to go ahead and turn it off, save battery here. You can't read that, but that said power off. All right. And I'll show you a picture of the leak that I just saved. Earlier. So there you go. That's what it looks like. It's just a JPEG file. A lot of our customers, all they really want is that JPEG image to put it in a work order. don't care about notes, the tags, all that kind of stuff, right? I'll show you another image here. This is a little different operating mode for the ii900, okay? This is called LeakQ mode. If you look at LeakQ scale here, right? If I put it in the LeakQ mode, I get this circle, and I've got a little video, so I won't try to explain all this. But you put the leak in the circle, the unit will measure the distance to the leak, and it'll calculate this value called LeakQ. LeakQ is like a severity code. That is, LeakQ is a figure of merit between, I think it either goes from 0 to 12 or 0 to 10. I really don't remember. But the higher the LeakQ number, the more severe the leak. This is something, I'll be quite honest with you, that initially Fluke said, we're not gonna try to calculate the cost of a leak because there's some problems really estimating the flow rate. We can hear it, we know the frequency, we know the dB level, we know how loud it is, but there's a little magic involved going from there to actually creating flow. But anyway, our customers wanted it, so we just added this, I guess, either December or January. Now, if you look back at the PowerPoint slide here, this is an example off the DOE website, and there's a lot of information if you're interested in pursuing this on the DOE website. It's a significant cost to manufacturers in the US, but they've got the equation here for calculating the cost of air leaks. Well, it's the number of leaks times this expression in the middle, and I kind of boxed that out because you really need to know the leak rate, CFM, and that's what's hard, you know, the volume of air that you're using. And then something you'll know about your compressor is how much energy do you have to put in to get this volume, right? So kilowatts per CFM. Then the number of hours that your compressor is running times whatever you're paying Duke Energy or wherever you are for, you know, for electricity. And then they run through some calculations. I won't do this, but they say, assume you have 100 really small leaks, 50, you know, medium size, and 10 big ones. If you can eliminate these losses, you can save $57,000 a year. So when you look at this, that $20,000 price tag on an ii900 doesn't seem as big. And I'm throwing that number 20,000 around because that's our list price. But I want to show you a little video on LeakQ, and then we'll be pretty close to finished here. I've got it's about what, 10:39, so we're not bad. So
you're good, Rick. But I do have a question. How do you? Is there a software package that comes with this that you're dumping or extrapolating those images into? And
there is, and in fact, let me. You see the survey summary here? This is the reporting tool. Right now, the reporting tool is on the website. They're trying to get feedback from customers to get it right, and then they're gonna make it something you could download and run off your computer. But you can do this with or without the LeakQ parameters. If you save an image in LeakQ mode, then these parameters get saved along with the image. If those parameters are there, then if you look at the little box on the upper right-hand side, it'll calculate the cost in US dollars, the way I did it, per year of a particular leak. Right? If you're not in LeakQ mode, excuse me, when you save the image, then you just get a picture of the image here. You can see with whatever details you entered on your tag ID, you may be able to see I've got notes on the bottom there. Another way to make a report, since it's just JPEGs, is you can just put them in a Word document. A lot of people are adding these, or just including the picture in a work order. So, let me back up. Now this Adam St. Clair here is start to say the product manager. He's not specifically another guy's product. He's got several products. Thermal imaging, the sonic imager. They both come from the same group at Fluke. But he explains LeakQ. So let's see.
Hi, my name is Adam, and in this video, I'm going to show you how to use LeakQ mode on your ii900. LeakQ mode is a mode that allows you to point the ii900 at a leak and get an estimated size of that leak. It'll also allow you to take the image that you capture and plug it into a reporting tool to get an estimated cost savings if you fix the leak that you find with the tool. Let me show you how to get into that mode. The first thing that you're going to do is turn on your ii900, and once it's on, you hit the touch screen. Then you select image in the upper left-hand corner, and finally select LeakQ mode. Once you see that circle populate in the center of the screen, you'll know you're in LeakQ mode and you can go capture some images. Remember, the key is to get the leak inside the circle in the center of the screen. Even if you're seeing noise and reflections or even a leak outside of that circle, you're gonna see this icon above that says no target found. Once you've got a leak positioned in the center, you're gonna see two things happen. One, the distance is gonna populate at the top, as well as the LeakQ scale. Then you're good to capture the image. As you move closer and further away from the leak, the distance value will change, but the LeakQ severity scale will not change. Capturing images in LeakQ mode is a little bit different than capturing images in the image mode or video mode with the ii900. Once you've got the leak positioned in the center of the screen and you've got both the distance and the LeakQ severity scale populated, you're gonna wanna push and hold the green button and hold the camera fixed on that leak for 1.5 seconds. If you have a leak positioned in the center of the circle, but you're not seeing a distance value, it might be because you're too far away, the environment is too noisy, or you don't have direct line of sight. But you can still get a leak quantified value estimation by manually entering in that distance. All you have to do is push that distance icon and manually enter the value. Now that your image is captured, you can add text notes, photo notes, or tags to the image, then download into the computer and generate your report.
Does that answer your question about reports, Nick?
Yes, it does. Thank you.
If you look on the left here, this would be the first page of a report. These are parameters that the user enters if you want to try to calculate the cost of a particular leak. Okay, so to calculate cost on an individual leak, you have to, one, capture the image in the LeakQ mode, which is really no different. Just you have the circle, right? And make sure your parameters are there. And then you come back and enter in, you know, what you pay for electricity, how long your compressor's running, that kind of thing. So, well, I really am pretty much finished. It's almost 10:45. I've got some specifications written out here. This one is a question I get asked a lot. Well, how far away can you see a leak? All right, this is, if it's compressed air, 100 PSI, 1,000th cubic foot per minute, you can see it at 33 feet. Now, the truth is you might be able to see it at 60 feet. One thing I've noticed that you, if you're looking for leaks in the distance, if you drop your frequency band, you may pick it up. As you get closer, you can up the frequency band and you get better resolution on it. You know, the sound waves, the high frequency sound waves just don't travel as far as low frequency. You know, you're sitting at a stoplight and you hear somebody's bass booming in a car, you know, 40 feet behind you, boom, ba boom, the high frequency sound is gone. It's just the low frequency stuff that's made it to you. So sometimes finding a leak at a distance, you'll kind of drop that frequency band. And as you get closer to it, you can get better resolution. The batteries, you get two nickel, or not nickel metal hydride, what are they called? Lithium ion batteries. They've got a little button on them so you can tell how much battery life. A dual bay charger charges one battery at a time, so they charge a little quicker than if you're trying to do both at one time. Battery life here, typically 6 hours. 3-hour charge time. Image storage, this may change with LeakQ. I'm not really sure, but it's almost 1,000 images, way more than you want to leave in a camera before you create a report, and 20 videos. The images are just JPEGs, videos are MP4. Actually, the video recording time has gotten longer. I'll show you my favorite video here. Also illustrates reflections. This is my counterpart in Tennessee with a leak in his lawnmower tire. But I like this because it shows, you can see the leak, you see the frequency band over here that he's working in, but notice as the tire spins, you see the reflection. So right now it looks like a leak on the shroud covering the blade of the lawnmower. Now it looks like the concrete is leaking, right? But they're line of sight, stable leak. So. Well, I'm done.
Okay, thank you, Rick. Hang on. Let me.
You want me to stop sharing my screen, or should I wait a minute and see if there's any questions?
Great. Thank you, Bobby.
All the videos I've shown you, except the lawnmower tire, at the Fluke website. There's also a return on investment calculator. If you're wondering if you have enough, losses or enough capacity to be concerned about, you can poke in parameters like how many compressors you have, how many horsepower, what do you pay for energy, and it'll crank out some numbers, some estimates for you. It's really based on the stuff that's at the DOE website. I think you can get all that there too.
Is that on your website, Rick?
That's on our website. Yeah, it's
okay.
In fact, am I still sharing?
Yeah.
All right, let's see if I can go to fluke.com. And the easy way to get there, well, you see the picture. If you see a picture of it, you can probably just click on that, depending on what they've highlighted. Okay. So now I'm at the ii900 webpage. You see the little video, little talk about the return on investment calculator. Under data sheet, testimonials. I thought they had something here called calculations.
Rick, scroll back up just a moment. It's right above that. It's right there. There's a hyperlink, try our leak calculator. That's where you're going to find that leak calculator, guys. You can't download it.
Right there. Okay. Yeah, thank you, Bill.
Yep.
So here's the leak calculator. I won't go through it, but
Okay, great.
here's the report generator. We're very careful on the report generator to make people or try to have people, and I'll stop sharing. Yeah, we want folks to understand that estimating the cost of a leak is kind of iffy. It's our engineers were saying, it's not that accurate. And everyone knows it's not that accurate, but people have been doing it for years. What it does, and the thinking is, we're going to create a work order. We want to give somebody a motivation to actually go complete the work. So we can tell that one leak is more severe than another. So I kind of look at it as a severity code, right?